Let's take a look at the meaning of linear programming, the commonly used terms and conventions, assumptions of linear programming, and its areas of application. You're welcome to my YouTube channel. If you're just joining me for the first time, you're welcome. Don't forget to like, comment, and subscribe to get updates of my videos. So kindly check the description section of this video because I shall be linking the computation of the linear programming topic because I have like more than like 3 or 4 computations that I've done already, both in the minimization and the maximization in linear programming. Do well to check the description section to check the link so that you can understand the calculation aspect of it. So let's get started. What is linear programming? Linear programming is a mathematical methodology of allocating scarce or limited resources to users such a way that will best achieve the objective of the decision maker. It employs mathematical expressions to model or program a problem solution. It is a constraint optimization technique which seeks the achievement of a single objective such as maximizing or minimizing a criterion in a model. You can check the calculation aspect in the description button or in the description section where I explain the meaning of minimization and maximization. The criterion could be profit or revenue related in a maximization problem. However, in the real world, resources are limited. Therefore, attaining the objective of maximizing profit or minimizing cost is constrained by the limitation of available resources. Note: linear programming technique can only be applied within all linear framework, a situation where the unknown variables in a criterion function and the constraint inequalities or equations are all linear under a condition of certainty. So what are the terms and conventions of linear programming? 1. We have the decision variables, a set of unknown quantities represented in the linear programming model by mathematical symbols, whose values are to be determined. When you go through the computation of the other video, you understand what decision variable is. 2. Side or structural system constraints, a set of inequalities or equations that express the relevant limitations or restrictions in terms of availability of resources in the problem situation being modeled mathematically. These limitations or restrictions determine the extent to which a resource can be used. 3. Right-hand side values, RHS. These are values that express resource levels that we seek to utilize. The right-hand side value is usually a constant represented mathematically by the symbol BI, where I denote the ith resource. The term right-hand side value originates from the positioning of the value on the right-hand side of each constraint, inequality, or equation. 4. Slack variables. These are variables that express the possibility of positive deviation of the sum of the terms on the left-hand side of a constraint inequality from the right-hand side value. Slack variables are represented in the linear programming by the symbol SI, where I denote the ith resource, and 1 is the number of side constraints with positive deviation. 5. Surplus variables. These are variables that express the possibility of negative deviation of the sum of the terms on the left-hand side of a constraint inequality from the right-hand side value. 6. Technological coefficients. These are numerical values or constants represented by AIG that express the per unit usage of the right-hand side resource. 7. Contribution coefficients. These are numerical values or constants represented by CJ that express the per unit contribution of each decision variable xj to the total or overall profit. 8. Cost coefficient. These are numerical values or constants represented by CJ that express the per unit of each decision variable xj to the total overall cost. 9. Z value. It is an unknown value that we seek to optimize either by maximization or minimization. 10. Objective or criteria function. A mathematical expression that equates it to the sum of the product of individual contribution or cost coefficient and the respective decision variable in a problem situation. 11. Tableau. A specialized matrix of numbers used in the simplex solution procedure. 12. Basic variables. A set of variables which can be either decision or slack variables that exist in the basis column of the simplex tableau. 13. Non-basic variables. All those variables, either decision or slight variable that are not in the basic column of the simplex tableau. These variables are also called zero variables as their value at the optimal solution is 0. So the next will be what are the linear programming assumptions? In a linear programming problem, the decision variable appear in the objective function and in the constraint in form of linear combination of the variables. The major assumptions are 1. The decision variables must appear only in linear relationships in both the objective function and constraint inequalities. 2. The decision variables cannot assume negative values. Non-negativity. This assumption restricts decision variables from having negative values since activities in real-world situation cannot be negative. The implication of this is that scarce resources cannot be committed to producing negative or imaginary products. Resources are either used in producing real products or are left idle. So what are the areas of application of linear programming? 1. Investment planning. That is financial mix, project selections, portfolio selection. 2. Transportation arrangement, cargo shipment, facility expansion, how to ship goods to customers with least cost, school enrollment and political redistribution. 3. Distribution management, most economical distribution network. 4. Production planning, that is what to produce and in what quantity. 5. Production scheduling, that is deciding which job should be done on which machines. 6. Assignment problem, it means matching people to jobs, work to machines, and contract to bidders. 7. We have advertising or promotional planning, that is media mix. It simply means selecting which advertising media will create the largest exposure to targeted audience. 8. Corporate planning. It means mapping out the best strategy for entire company operations. 9. State security, strategic military effectiveness analysis. 10. Blending. 11. Military applications. 12. Agricultural applications. So I just want to chip in something. The concept of linear programming actually originated from the military because they were the first person to adopt the technique, and due to its 100% effectiveness, other sectors of the economy started making use of it, and they could also see the good effects in some sectors, in some areas. So in my next video, I shall be talking about the advantages of using linear programming for decision making and the limitations of the linear programming technique. Thank you so much, guys, for staying tuned. Don't forget to share and like and subscribe, comment if the video has been good to you. I also have a playlist of management science courses you can kindly check. See you guys in the next video. Stay tuned, stay blessed.